I need to mount a Hotend camera to this printer for better monitoring of my prints. I could use simple shapes that are easy to 3D print, but I wanted to try letting the software handle the design for me. Stick around to find out how. Generative design isn't new, but it's becoming more accessible to people like me and you, and it can be very useful for reducing waste while still ending up with a strong part. This method takes care of the connections for us. Our job is to give it guidance so it can better understand what we're trying to achieve. Because the fan shroud limits visibility, I need to remove it. I want to use all of the original mounting holes so everything can be brought back to stock. The results need to be strong, it needs to limit vibration, and it should be lightweight. With this method of design, we focus on the mounting points and the limits of the part to make sure it knows it cannot add material beyond the locations that we set. So here's what I've come up with. And yes, this looks simple and not impressive at all, and that's the point. It makes changes later on very easy for us, and the computer can handle the rest. In order for the software to know how strong the parts need to be, we need to pick a material. And the material for the default is aluminum. I'm going to pick ABS instead, and we'll delete the aluminum. The more materials that you choose, the longer the calculation process seems to take. We'll be 3D printing this part, and again, to further reduce the time to come up with the design, we'll choose additive only and select all orientations because I can print this part with supports. These are the bolting locations. They are the points we need to retain completely. They may be enlarged beyond what you see, but they cannot be made smaller. We also need to add clearance for the field of view of the camera, so I've added this cylinder with a fillet on it. And here are the areas I've set for barriers for the final part. We also need to include clearance for the shaft and head of the bolts, as well as a path to actually install the fasteners as well. Next, we need to assign the areas that we want to keep, and then set one of them as the fixed position. This will be the area that's mounted to the X carriage. And now we need to assign the loads, and the loading requirements here are small, but I still need the result to be stiff to resist vibration. The loads that we apply have a big impact on the final shape, so this is the good area to spend most of your time. In my case, I've assigned loads much higher than what's needed. This will also help when printing the part because there will be larger cross sections to print. In my case, I also have rapid changes in direction in the X-axis, and I've applied loads to compensate. I've also added loads to the mount for the fan, and this is mainly because I want the post to be thick enough because of the weakness of the layer lines in that print. And now the software allows a preview of the part before generating the various options. The preview shows the extremes of the part, but it will not resemble the final designs. The generation process for this part will take approximately 1 hour because we minimize the options. Now these designs look just incredible to me. They're organic and artistic. Creating something like this manually would be tough, and they'd still look pretty basic. The software has left us with a few options, and each of these can be reviewed or compared. Now when we lower the loads on only the fan mount and change the direction, it results in completely different parts. I've chosen a design from a previous generation which has had heavier loads applied, and the result was a much more solid part. The downside of something intricate like this is that it'll be hard to print with good results. The design does require heatset M3 inserts, as well as M3x6 button head screws, and some tiny eyeglass screws for the mounting of the Pi camera. One side benefit of something like this structure is that it can be modified by adding a little bit of heat. This is just the beginning of this design for the Pi nozzle cam and fan mount. The camera could do to be a little bit closer to the nozzle. Maybe we could add a threaded adjustment mechanism. And this camera could be swapped out for the 8 megapixel version. And I've also kept it away from the build plate because having the camera too close to the heat bed may cause problems over time. It is rigid, it doesn't vibrate. and it helps me to identify problems like blobbing and stringing during the printing process, unlike when you view from a distance. Originally, I had attempted a borescope mount with a close-up picture, but I really wasn't happy with the result, and I do like the simplicity of using the Pi camera instead. I still need a better method for keeping the camera at the correct angle during the print, but also being able to change the angle back to adjust the focus. So maybe a switch to a different style of camera completely would be a good idea. Please let me know about your ideas for development of this system and if you think it's worthwhile. All of these parts are available for you to download if you'd like to create the setup on your own printer, as well as links for any of the parts needed for the setup. I hope you enjoyed the video and found it helpful. Please make sure to subscribe, like, and hit that notification bell for heads up on future videos. Take care everybody, we'll see you on the next one.